So the main proof methods that we are going to talk about today, and today we are just going to talk about proving statements that not everything usually are of the form P implies Q. That's the most like high yield things that we're going to do. What are the three proof methods that you guys know of for those? Direct proof, excellent. What else? Contrapositive contradiction, excellent. Okay, and I'm going to talk about each of those, what they mean, and how to do them, okay? Can someone tell me, when you do a direct proof, what is your assumption and what are you trying to prove? This is the same thing. Let me just open the chat. Okay, assumption in a direct proof. What do you assume? Ignore me writing, guys. So I'm just going to keep writing. I want you to say, what do you assume in a direct proof? Exactly. And the reason I'm really asking you all is because we talked about this. You already did a quiz which had this direct proof asked. If A is a subset, blah, 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 then prove this. That's basically this. So you assume P is true, show Q is true. Contrapositive. What's the contrapositive statement? Very, very, very important. What's the contrapositive of P implies Q? So it's logically equivalent to P implies Q. It's not quite Q is false. It is not Q though. What's the rest of it? It's not Q implies not P. That's what contrapositive is. And again, this is it might sound very confusing, but think in English. Okay. So for example, I can say, if I had finished surgery early today, I would have gone to UTM. This is the same as saying, I didn't go to UTM because I didn't finish early today. Do you see the same basically, like in English? So I'm saying, if I had finished surgery early today, I would have gone to UTM. Conversely, I can easily say, I didn't go to UTM today because I didn't finish early today. Or I can say, I didn't go to UTM today, hence, I didn't finish surgery. Like, you can also think of it like that. If like statement one is me saying, and you have to assume, like believe that I'm telling the truth. If I had finished early today, I would have gone to UTM. That's the truth. Now, the fact that I didn't come to UTM then means I didn't finish surgery early today. Does this make sense? That's basically contrapositive. Maybe this is not the best example to use in English. My brain is fried right now. But like, come up with an English day-to-day language statement yourself where it makes sense. Guys, someone say something in the chat. I have no idea if you can even hear me. Does this make sense? Okay, good. Now, another thing is you can use truth table to convince yourself that they are the same thing. I mean, the green, right now we talked about the logic, but if you want to see, like, conceptually it makes sense, they're the same, but if you want to convince yourself, you can use the truth table and see they're the same. Okay, In contrapositive, what is your assumption? Awesome. And what do you show? Awesome. Let's now talk about contradiction. Okay, now contradiction is slightly different. So what does contradiction mean? Contradiction means a statement which is always false. I don't know if you've heard the word tautology, but tautology means a statement which is always true. Similarly, contradiction means a statement which is always false. Okay? So basically, what we do in a contradiction proof, the concept behind that is we assume, assumption is negation is true. And I'll talk about that in a second. And we'll show contradiction attained. So basically, if I assume the negation is true and that leads me to a contradiction, then that means my negation assumption was false, right? So because of this, so let me write this, which means assumption was false, i.e. negation is false, assumption wrong, which means original statement is true. This is a concept behind contradiction. Any doubt in that before I go into what is negation and all that kind of stuff? Any doubts? I don't see.
No,
Good. What's the
no.
what is the negation? Did you have a doubt? Sorry.
Hi.
Yeah.
Oh, I was just about to ask. Like, I always mess up with contradiction.
Mm-hmm.
Like, is it usually just like because realistically, it's not like the full negation of the statement, right?
It is the full negation.
Really?
It is the full. It's learning how to take the negation, which is why last week's tutorial we spent so much time on taking negations properly. Because the full negation doesn't mean every equal to sign becomes not equal to every inequality switch. No, that's not full negation. Full negation means conceptually what is the negation of the statement? What is the
So,
exact opposite? And we'll do some examples where you will see. So if you struggle with that, more than the proof by contradiction, maybe spend more time in negating statements. So you're more comfortable taking negations, then do the contradiction proofs.
yeah, like I just found like sometimes some of the questions are not like even if it's not if then, you don't like tend to negate the end of it. You know what I mean? I mean the beginning of it. You usually like negate the end of it. Is that weird? Like I or is that am I just like confusing
Okay,
like implication?
find a question like that and show it to me because it's hard
Okay.
for me to visualize what you're saying. Yeah.
Okay, okay,
And
okay,
we'll
okay.
do some contradiction questions today where the negation, it's not technically P implies Q. We are just going to use the concept of negation as opposite.
Yeah, yeah, that's what I meant. Yeah, that's kind of what I mean. Like it's not like
Okay. Yeah.
yeah.
So if you're finding a question where it looks confusing, just bring it to me in office or something and we can discuss it.
Okay, thank you so much.
Okay. So in general, for P implies Q, what is the negation of P implies Q? We talked about it last week. And this is for everyone to answer. What's the negation of P implies Q? Also, P and not Q. So my assumption is P is true and not Q is true. Okay. So this is a general structure for proofs. Not structure, the concept and the structure technically. So this is the structure, the assumption, and to show. This is vital that you understand this. And if we are asking you to do one method, do that method. Also keep in mind, not P implies not Q is not a thing. That doesn't exist anywhere. A lot of people end up doing proofs like that, and I'm like, I don't even know what that is. If you do the truth table, you'll see P implies Q and not P implies not Q are not logically equivalent. They are not the same thing. So don't do not P implies not Q. Very common mistake for some reason. Now let's spend some time thinking about which. Another thing I want to mention is read this question yourself. I'm not going to do this or anything, but I just want to mention that a lot of questions you can do it in more than one method. And there is no right or wrong answer. Like here, this is a bit longer, you can see. But if we don't tell you which method to use, you're technically free to use any method you want. That being said, realistically, some questions, I mean, by theory, every question you can do every method. In reality, some questions, it's just extremely difficult to do certain methods, and our certain methods are easy. So when you get a question in the test, if we tell you do it by contrapositive or like do it by contradiction, then use that method. If we don't tell you, you need to spend some time thinking about which is the best method to use here. Again, it could be more than one method, then do whatever you like. But otherwise, sometimes there is a better method to use. So I'll give you some tips and tricks to how to navigate that. At the end of the day, the more practice you do, the better you will be at knowing which method to use. But there is some things we can talk about. So let's first see. In direct proof, remember, we were talking P implies Q. So in direct, we are using P and Q. In contrapositive, I am working with not Q implies not P. So I work with not Q and not P. In contradiction, I assume P and not Q is true, which means I work with P and I work with not Q. So you can see all three of them are working with a different pair of statements. Sometimes, not always, a lot of times, no, just looking at, okay, what is my P here? What is my Q here? What's my not P? What's my not Q? Is it easier to work with P or not P? Is it easier to work with Q or not Q? And making that decision can help. Not always, but sometimes. For example, and sometimes this is all uses. Let's talk about this is all uses. So I know the answers are given, just ignore the answer for a second. Show that there are no rational solutions. So if I had to do direct, I would actually have to show there is no rational solution. It is extremely difficult mathematically to show no rational solution. The only way is to find the roots and show they are not rational, like one by one. Again, depending on the equation, finding the roots might be easy/not easy. But in general, randomly given an equation to find the solution and showing they are not rational is not easy. So direct, again, could be possible depending on the equation, but generally not a good option. Contrapositive is just like a bit tricky here because I don't even know what's my P and Q here. Could you translate to a P implies Q statement? Theoretically, yeah. Do you want to spend time doing that? Absolutely not. Why are you wasting your time, kind of thing? So I don't think that's worthwhile here to make it P implies Q and find contrapositive and all that. So I'm just going to ignore that. Contradiction makes perfect sense because contradiction would assume there is a rational solution and show something goes wrong. So contradiction will be assume the opposite. What is the opposite? There is a rational solution. And then you do stuff that you do, and you reach a contradiction. Because you reach a contradiction, your assumption was wrong, which is your assumption is there is a rational solution. That's wrong, so there is no rational solution. Now let's see this in practice before we move on. I'm not going to do this question. We'll do a similar question. Oh, is it the same thing? It's not the same thing. It's slightly different. So if you get no rational solution, so suppose for contradiction, assume there is, let's just add assume there is a rational x which satisfy, and then you define what rational means, you simplify, you get contradiction, 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 and you say, overall, if I make this assumption, I always reach a contradiction, so my assumption was false. Again, I'm not doing this question right now. Read it yourself, but it's just the concept that I want you to understand. We'll do another similar question, so don't worry. Does this make sense? Why contradiction is a good option here? Again, maybe we'll take a pause on that, do a question, and then hopefully it will make more sense, because we didn't do it now, it might look confusing. But just recognizing contradiction is a good method is the key here. Now let's look, for example, at this question and why contrapositive works a bit better there. So let's see what my P is, what's my Q. So my P is x squared minus 1 is divisible by 8. X is even is my Q. My not P is x squared minus 1 is divisible by 8. My not Q is x is odd. Now if you take a look, comparing P and not P, how do you write x squared minus 1 is not divisible by 8? That's a bit tricky to write mathematically. That means x squared minus 1 is not equal to 8k, where k is an integer. Or in other words, you can say x squared minus 1 is equal to 8k plus, I don't know, a, where a is 1, 2, 3, 4, 5, 6, or 7. That's what this means. K is an integer. Whereas not P is so much easier to write mathematically. It just means x squared minus 1 is equal to 8k, where k is an integer. And Q and not Q are comparable. Like x is even, x is odd. Not a big difference. Mathematically, they're very similar. But not P is much easier to work with. So when I go back, contrapositive is the only one working with not P. So that's a hint. Again, guys, this is not an absolute method that you can use for every question. Some questions, this will make no sense. But as a starting point, this is a good way to start doing these questions, okay? So that's one way to know contrapositive is the best choice here. And like, for example, this is direct because this is my P, this is my Q. My P and Q are both talking about divisible by 3. My not P and not Q will say not divisible by 3. And it's like so much harder mathematically to write not divisible by 3. So I would just do a direct. Like, does this make sense? If you look at question 3, this is going to go slightly opposite. So question 3, if you take, my P is going to be x cubed plus 5x equals 40. My Q is x less than 3. My not P is x cubed plus 5x is not equal to 40. My not Q is x greater than or equal to 3. So technically speaking, if you compare these two, equal to 40 is easier to work with. But so you might think, not contrapositive, like direct might be a good method to use here, or contradiction. Technically speaking, you can do direct and contradiction. It's not wrong. But if you do direct and contradiction, you will have to find x. You'll have to solve for x. And I'm pretty sure this x is just going to give you like some like decimal or something. So if you have a calculator or if you know the cubic equation formula thingy, it's possible. But otherwise, it's so hard to solve for x. So this is a good question where just thinking was P or not P easier to work with, not enough to know which method to use. That's just a starting point. Here, if you just use that P is easier to work with logic and you started a proof, you'll get stuck and then you'll have to go back and revisit and then you'll realize it's much easier to show not Q implies not P, which is contrapositive. So so the key here is to understand the logic I'm telling you is just a starting point. Once you have that, do lots of practice, get your hands dirty, think a lot, and the more you do, the better you will be at recognizing which method to use. Does this make sense? Any questions? We're going to start doing problems now. Last call for questions. Okay, I don't see any. So you are told prove by contrapositive. If you are told prove by contrapositive, I'm going to say this one more time. Please prove by contrapositive. If we are told to prove it by a certain method, you have to use that method. Otherwise, you will not get marks. So first thing you need to recognize in questions like this is making sure you have your statement for contrapositive written correctly. Like usually that is worth mark. Writing your contrapositive statement, that's usually worth marks. Okay. Worst case scenario, everything else is wrong, you'll still get like 1 out of 3 or something. It's like it's actually worth a decent amount of marks. So what's my contrapositive statement here?
Oh, can I do it?
Sure.
So here, the counterpositive statement is if A is even, then A squared minus 4B is even,
So
right? Yeah.
yeah, awesome. And you write this is worth marks. So don't skimp on this. And the question is contradiction easier to solve? Do you mean in this question or in general? Shania? This question. I don't think it's easier. It's you can do contradiction 100% and get the answer. I think difficulty is going to be very comparable to the contrapositive. It will look similar, but they're different. So this question is a good example of where you can totally do contradiction here and get the answer with no problem. But if you did contradiction, you wouldn't get marks because the question is asking you to do contrapositive. So this does happen. By the way, this is a fall 2021 term test question. So people who did contradiction, I think got like half or 1 out of 4 or something, even if the answer was correct. So yes, the difficulty won't be much different either. So that's if you for good practice, just try contradiction also yourself. Okay, so what's my assumption here? Assume A is even. Excellent. Now I want to show A square minus 4B is even. So whenever you have A is even, A is odd, this just write out mathematically what this means. This means A is equal to 2k for some k in the integers. Now, keep in mind, I always go back to what do I need? I want A square minus 4b. So let's find out what that is. This is 2k square minus 4b, 4k square minus 4b. This is just 2 times 2k squared minus 2b. Okay, so this is an integer since k and b are integers, which basically means, I mean, then this step is just b being extra. But being very thorough. So a square minus 4b is also 2 times an integer. So a square minus 4b is even. Now, if you want to be complete, then you will say, so contrapositively, a square minus 4b odd will imply a is odd. Does this make sense? Look how easy the math part of this is. The key was recognized. First of all, making sure you do contrapositive correctly. A lot of people did contradiction. A lot of people did not P implies not Q, but again, don't do that. And then a lot of people, I think those are the most common issues. Like the math itself is like pretty simple in this question. Any questions, any doubts? Can we do the next question? I need some opinion, guys. you have a doubt, let me know. If you can do the next question, let me know. Okay, one person says no doubt. I don't know about other people here. Okay, everybody else in the class, what are you guys doing? Do you have a doubt? Or okay, good. 2 people said I'm gonna move on. Let's do the next question. Here you are not told which method to use, so you have to decide yourself. This question is annoyingly long, which I didn't realize before I put it. So winter 2021, okay? So you have an if then. So what is my P? What is my Q? What's my P? I'll write my P. I want you guys to tell me what is my Q, and I'll write it out. I want you to tell me what that means. Can someone tell me what this means? N and M cannot both be odd. So what does that tell you? What's another way to say? At least one of them is even. Excellent. So that means there are 2 cases, not 3 cases. N and M are both even. N even, M odd. So when you do a question like that, you basically have to take N odd, M even. So in questions like this where they talk about, oh, N is all, like, very common to have questions where the statement you have to prove will be like, oh, both of them are odd, or at least one is odd, or at most one is odd, or they are not both odd, or they are not both even. Like these wordings come up all the time. So when you see this, just write out the cases so you don't like miss it out. Like technically, when you have 2 numbers, you have 4 cases, both even, both odd, first one even, second one odd, first one odd, second one even. That's your 4 cases. So when you see questions with these wordings, out of those 4 cases, write out which 3 cases fall under the wording they give you. This will make sure when you take your negation, you don't mess up. A lot of people mess up when they take the negation. Again, here it will look simple, but it can become very complicated, the wording. So be very, very sure. So now our negation is the 4th remaining case. Okay. And not P will be this thing has no rational solution. So which method do you guys think we'll use here? Based on the logic I said, like is P or not P easy to work with? Is Q or not Q easy to work with? Contradiction, exactly. It is contradiction. So how I would think about it is focusing on the P part. So has no rational solution is very difficult to show for an equation. A lot of people were like, oh, from last tutorial, so let's just take the discriminant. I can't take discriminant. Discriminant talks about real solutions. This is talking about rational solutions. There is no mathematical method for me to show it has a rational root. The only way is to actually find the root and then be like, hey, this is the root and it's rational. So it's very, very difficult, to show no rational root. Because the only way to be is like find the root and show it's not rational. To show it is rational, I just say R equals A by B. That's different. We'll see that. But if I assume it has no rational solution, it's hard. Like if it's real, yes, assume no real solution. It tells me discriminant less than 0, and mathematically I can move on. But if it's assumed it's no rational solution, like how do you write that mathematically? It's very difficult. So that helps me rule out not P. So that means contrapositive is gone. Now, direct versus contradiction, again, when you start doing direct, you'll see it is really long and like it's kind of very tedious. That's one way to find out. Another way I would have just decided is like not Q has only 1 case. Q has 3 cases. So not Q is just easier to deal with. So P and not Q are easier to deal with. So the method that deals with those 2 is contradiction. So that's one way, not the only way. Like conceptually, there's better ways to think about how you know contradiction, but starting point, that's one way to recognize this as contradiction. So assume we're doing contradiction. Negation is true, which is P and not Q, is true. Which means let M and N be integers. Assume x squared plus mx plus n equals 0 has a rational solution. That's the P. And N and M are both odd. Okay. Now I'm going to write out what this means in math. So let R be the rational solution. Of x squared plus mx plus n equals 0. So if R is a rational number, it means I can rewrite R as A by B. Okay. Do I need to add anything here? Is this just what it means to be rational? That's a fraction. Or is there any other further conditions to this fraction? If I'm asking that, then there should be conditions. What are the conditions to be a rational number? Again, this is not 102. This is all like high school or middle school math. What is a rational number?
Oh, can I answer?
Yeah, anyone can answer.
Uh, um, it's basically it's when both A and B are integers in its
Mhm.
lowest form, right?
Awesome.
Right? Yeah, yeah.
Oh, yeah.
And yeah, and A and B, the fraction it creates is in its lowest form.
Yeah. Is that it?
Um, I knew I think I might be missing something.
What's the most
Uh,
common condition we write when we have a fraction? When we have a function and all that, we say denominator can never be what?
the denominator can't be 1?
0.
0.
Because
Oh.
then it's not defined.
Oh, right. Yeah. Whoops.
That's okay.
I
So
thought,
if
wait,
you don't write this, you won't get marks. I'm going to say, because your contradiction comes from this. So if you don't write this, you won't get full marks. So this is vital. I'm going to say it's 500 times. And people will still not write it. I mean, half the people are not even here. So anyway, so if you don't write this, you will not get full marks. So please write this. Please, 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 please. I mean, the last step, you can also write GCD. If you know what GCD is, you can say that. Like, it's up to you how you word it. But basically, it means you have no, like 2 by 4, 3 by 6, nothing like that. It's written as 1 by 2. You can't make it any smaller. It's written in the lowest form possible. So that's that. Now the second assumption is n and m are both odd. So let n equals 2k plus 1 for some k in the integers. M equals 2k plus 1. Anything you guys want to add or modify in what I just wrote down? I'm asking, obviously there is a reason if I am asking. Something is wrong in what I wrote. What's wrong? Okay, this is like saying n equals m because they both are 2k plus 1. So this is saying n equals m, so I can't do this. I need to use a different variable. Otherwise, I'm basically saying they're the same thing. Does this make sense? Because it's very important you see why that's the thing. Because if I use k for both, I'm saying they're the same thing. So if you use two different variables, you're working with two different variables, don't give them the same names and all that kind of stuff. Make it very clear when elements are not the same. I'm just gonna keep going because I don't see in the chat if there. This is hard because when it's in person, I can see your facial expressions. When it's online, I cannot. Um, so it's hard for me to know if you are following or if you can hear me and all that. So if there is any issue, just put it in the chat. So substituting for all of this, a by b the whole square, m times a by b plus n equals 0, a squared plus ma plus n equals 0. Take common denominator, a squared plus mab plus nb squared equals 0. So now this is the equation I'm working with. So when you're working with these questions, you have to do some practice to recognize these are the cases you have. If you go back to the rational roots question that I showed in the beginning, you'll see that this is exactly the same case, logic. Like you go, assume there is a rational root, plug it in, simplify the equation, and then you basically do cases. Again, if you're doing this for the first time during a quiz, it's kind of impossible to figure out this is the cases you need. But the more practice you do, very common questions asked. So you will see the rational root questions is 99% of the time these cases, and you're going to reach a contradiction. So what's the issue if A and B are both even? Why is this a contradiction? Please look at our assumption. Guys, please engage, please participate. I can guarantee I had a much longer day than all of you combined. If I can talk, you guys can talk too. I have written down the assumption. I told you guys we will need this for the contradiction. I'm going to highlight it now. Please tell me. Why is this an issue?
Uh, Hello?
Yeah, I can hear you. Go ahead.
So you're asking why number one is an issue?
Yeah,
It's an issue because it's not in its lowest form. If it's an even on the top and an even on the bottom, then that implies that it can be in a lower term, right?
excellent.
Yeah, so that means that you've arrived at a contradiction because that means that um, there is no rational root.
Fair enough. Okay. So we are only working with rational numbers in the lowest form. So because everything else is a repetition. So we have already reduced our number to the lowest form. So now it can't have both even. Numerator and denominator are both even because if they're both even, it's not lowest forms. Exactly as you said. So that's why it's a contradiction. All the other three contradictions are just like a lot of calculation, which I don't want to do. I'll do one of them. I'll show you what to do. You're going to do the rest and I'll post the rest. So A is odd and B is odd. So the equation, let A be 2 alpha plus 1 and B be 2 beta plus 1 for some alpha and beta in the integers. Now the equation will become 2 alpha plus 1 squared plus, what was M again? 2L plus 1. 2L plus 1 times A is 2 alpha plus 1 times 2 beta plus 1 plus, oh goodness, NB squared. 2K plus, I told you guys, it's very tedious. I'm not a big fan of this at all. The people who had to write this for a quiz, I mean, it's not difficult, it's just so long.
We like basically last semester on the test, we
Uh-huh.
like basically had to do a similar question,
Uh-huh.
but we had to take it in each case, like for even odd, all four cases, and write down all the explanations, which
Last
is
semester it is not really long though. This one is much longer, in my opinion. But then obviously when you write the test, you feel that's longer than past tests.
it
You all
felt like a decade I took on that. Like it was quick because I've practiced it before, but that question literally felt like a decade. Like I was just writing constantly, and I was petrified that I didn't write enough because it's like
It's, I know, right? Like it's the trick with these things is like how much do you need? And the
yeah,
answer to that is depends on how much it is worth. So if this was 3 marks, how much detail you need is different from if it's like 5 marks.
right,
So you have to like be a bit strategic in how much detail you're giving.
right,
So theoretically, ideally, if this is an assignment, I want you to sit and open up all the brackets, simplify, and do this. If this was a quiz, I feel like from here onwards, you probably don't need to open up all brackets and all that. I'll probably be like, oh, this is odd, square is odd. This is odd times odd, which is odd. And this is odd times odd square, which is odd. So finally we have odd plus odd plus odd, which is what's when you add three odd numbers, what do you get? Odd number or an even number?
odd.
Yeah, you get an odd number. RHS equals 0, which is even. I mean, ideally, guys, you should be actually opening up the bracket and all that. I don't have the patience for that. This is a contradiction. You will get exact same contradiction in the other two cases. The LHS will be odd and the RHS will be even. That's the same issue, but do the work yourself. Okay? I homework because I don't want to do that. So big picture, the learning here is all cases lead to a contradiction. Okay, so all cases lead to a contradiction, which means assumption is wrong. Assumption, i.e. negation, is wrong. So original statement, just the P implies Q, is true. Does this make sense? I am going to go like 2 or 3 minutes over because there's one more concept I want to teach before you guys leave. I apologize for that in advance. If you have somewhere to be, you're free to leave earlier. Any questions in this? Does this make sense? Do more practice with this. If you go back and look at this question now, it will make more sense. Like this would look shorter now. Question 2. Show that it's the same thing. Both even, both odd, one even. One even, one odd. Yeah, that kind of concept. Okay, awesome. I am not seeing any questions. So then I'm going to do the last question that I wanted to cover. I'm not doing the full question. I just want you to see this type of questions, another very common contradiction question that comes up, which is show there are no natural solutions. So rational versus natural versus no real, all of them look very similar questions, but how you do them are very different. Generally for no natural, like again, it's going to be proof by contradiction. Assume there is a natural solution. The key here is usually, so assume there is a natural x comma y, let's call it x naught comma y naught, such that x naught square equals 7 plus 4 y naught square. In general, for these questions, what you're going to do is you're going to use difference of squares. Generally. And then product I'm going to just leave it as, say it is product. It's not product rule, but like general product concept. So, or difference of square is basically or product of two numbers. It's not always difference of squares. It's product of two brackets and equals a number easily broken down. And this is going to sound weird. I'll tell you what this means. Okay. So you basically want something like AB equals to a number, and this number is usually prime, or it can be something like, I don't know, 9, where it's, or 6, where it's not really prime, but it's like easy to see what the products will be. Like, do you know what I mean? Like it usually it's prime, but it's not need not be prime, but like you can easily find the cases which give me that product. Generally, not always. No natural solutions and all that follow this logic generally. So you want to rewrite this equation as a product of two brackets on the one side and a number on the other side, the number which you can break down. Usually this is difference of squares, and I'll show you why difference of squares makes sense. So if you look at this question here, so this you can write as x naught square minus 4 naught y naught square equals 7. So the good thing about difference of square is you can make it into the product of two brackets very easily, which is why difference of square makes sense. So now you see I have it in this form. Product of two brackets and an easily broken down number. So I have two numbers giving me 7. So the only possibility is that they're either 7 and 1, 1 and 7, -1, -7, or -7, -1. And then you have to go, so these are your cases. And you have to take each case and say how all of them will lead to a contradiction. I'm not doing that part, the answer is given here, but all of them will lead to a contradiction. That's the logic for no natural solutions. Does this make sense? Okay, I see someone say yes. If that makes sense, now my question here is, if you do this, what is your equation going to be before you do cases? So again, you will assume there is a natural solution. Again, I usually, not always, I'm trying to get, basically I'm trying to get product of two bracket of variables equals to a number that you can easily make into a product breakdown. And generally, if you see squares, you probably need difference of squares. If you're seeing squares here, so the product is going to come from difference of squares. So how can you make this difference of squares on one side? Again, this is not 102 math. This is high school math. How do you make this perfect squares here? Some guesses, guys. The longer you wait, the longer I take to finish. I need some guess so I can build off that. You know what, at the time limit, so I'm not. Oh, excellent. Excellent. Yes, yes, yes. So a lot of people told me last tutorial just do this. But then the problem is there is a 2x naught. So this one I can make into a product, but like what do I do with this? So I need to get rid of the 2x naught. And the suggestion that came is exactly what I do, which is I rewrite this equation like this. And recognize this is x naught plus 1 the whole squared plus 2 equals y naught squared. So now I can do x naught plus 1 the whole square minus y naught squared equals -2, which is x naught plus 1 minus y naught, x naught plus 1 plus y naught equals -2. So now I have it in that form where it's product of two brackets and it's number that's easily broken down. So this basically means case 1 is 1 minus 2, case 2 is minus 1, 2, case 3, is there a different case? I don't think so. That's it, right? I think that's it. How did they have more cases earlier? 1771 minus 1. I'm doing something. Oh, there are more cases. 2 minus 1 minus 2 1. Yeah, that's the cases. So you have to do 4 cases and all of them lead to a contradiction. Solve for x naught y naught. Does this make sense? And again, I'll post the answer, but I just wanted you to recognize, like, seeing the question and just knowing how to rearrange it to get it to the form you want. Any doubt in that? Before you guys leave, again, there is find natural solution, so that's different. I'll also post midterm checklist, midterm practice questions, intro to induction. So you solve this study, please spend some time. Sure, you can ask. Does anyone have any tutorial questions? If not, you're free to go. And if I'm sure no one has any tutorial questions,